Okay, so welcome back to another video. Here's a ginormous indefinite integral we want to calculate. Thank goodness it's not a definite integral. So as you can see, there is a lot of natural log functions inside of it. We have the natural log of the natural log of the natural log of the natural log of x. Add this with the 1 divided by the natural log of the natural log of the natural log of x. Multiply being 1 divided by x times ln of x, and then follow up with dx. So you can probably tell from this that your first intuition on your first objective, of course, from an assumptions point, is that we would have to perform such a u-substitution. And you would be correct on that. But this is kind of more of a guessing game rather on what are we supposed to substitute. Because as you can see with a bunch of natural log functions, you probably think we just substitute just ln of x. There's a possibility that we might substitute instead with ln of x, or ln of x, or, the full thing, so on and so forth. But when you choose the right, we choose the right, so that's where I come in to show you this. When you choose the right substitution, you'll see that everything is just going to clean out nice and easy. And of course, the answer itself is, I think you could probably guess, it's going to be still involved with a bunch of natural log functions of, of such a long caliber like that. So this is pretty much going to be an interesting one. So with that being honest, nothing more that needs to be said. We'll actually just jump right in. So we'll just say this is capital I, and now of course, as mentioned, this is a u-substitution. So if you guess the natural log of x being the substitution, well, you are correct. You have indeed hit the money marker. You've hit the jackpot. So with this being the case, natural log of x will set that equal to y. Then that means we have that this is going to be dy is then equal to 1 divided by x times the natural log of x. So with that being the case, so then dx, then we substitute everything back in. So the integral, so just be careful when you write this. Don't want to write too many natural logs, and then it's just going to go into a fury of chaos everywhere. So that means I have the natural log of the natural log of y, okay? And then add this with 1 divided by the natural log of y. And then thankfully dx 1 over x ln of x dx, that'll get rid of itself. So we're just left with dy by itself. Okay, so then why don't we actually split this up so that we actually are dealing with a sum of indefinite integrals. So with, that means I have now the natural log, or the integral of the natural log of y, then dy. Add this with the natural log, or the integral of 1 divided by the natural log of y, and then dy. Okay, so this integral is kind of self-explanatory. I don't think that's not going to be that bit of a challenge, but with that, why don't we actually just pay attention to the first integral, so the natural log of the natural log of y. Okay, so with this, let's actually let it be u equals the natural log of y. So that means what we notice is that actually what we're going to do, I forgot to explain this before I do all of this, we're actually going to perform a nice little integration by parts substitution. So we're going to choose our u and then find our dv. It's kind of self-explanatory to see which of the pieces we can actually pick from here. So then we're going to have that du, so differentiate this is going to be 1 divided by y, ln of y, and then dy. Choose our nice little dv, that's going to be, of course, dy, and so then v is going to equal y. Okay, so now over here, if we just plug the pieces together, so we have u times v, so that means I have y times the natural log of y, okay? And then subtract this with, so multiply the v times du, so that means I have y divided by y, ln of y, and then dy. Okay, so as you notice that the y's are just going to cancel itself out. Then now if we actually just put everything back together, so I'm just going to write this as, put that back as capital I yet again. And I actually take that back when I say self-explanatory, because I'm just looking at my notes. I actually just realized that you're going to notice that we're going to have some terms that cancel out. So I have y, the natural log of, you see where I'm coming from with this? You can actually get yourself mixed up no matter how many times you say natural log. So y times the natural log of y And then, so that means those two are going to cancel each other out. So let me actually just write this out in full first, and then I'm just going to use the marker to cancel the terms out. So natural log of y dy, add this with natural log, or 1 divided by the natural log of y, and then dy. Okay, so as mentioned, that's just going to cancel these two terms over here. So we're basically just left with y ln of y. So pretty much we're kind of just done here. So that means equals c. So don't forget, because this is a definite integral, so we have to put in our constant c. So ln of y, then plus c. But everything's in terms of x. We actually start back from the very beginning with y equals ln of x. So now let's just put everything back together. So then the final answer would have to be the natural log of x. So that was where the y comes in. Then we multiply by the natural log of y, put that back in. So that means I have natural log and then another natural log. So 4 natural logs in this combination over here of x. So that means I have 1, 2, 3 parentheses to close off, and then just finish off with adding c. So therefore we have found our solution to the indefinite integral of a natural log frenzy. Everything just like that just comes together. Simply as that. Well, as mentioned, thankfully we don't have to do a definite integral with this, because I'm sure that that's going to be a pretty confusing number. Well, we didn't have to write it out in the form of a decimal form, if anything, but it's just at least we found something of a nice close form. So there you have it. And yeah, that's pretty cool if you ask me.